Good evening, everyone. I welcome you all in a Sapience Education. For more details, you can visit our website www.sapienceeducation.com. Today, I am going to teach you a chapter, some part of the chapter that is mechanical properties of fluid, where we will able to understand what is actually angle of contact, excess pressure inside the liquid drop, and bubble capillary rise in the tube. So, first of all, we need to understand what is angle of contact in liquid case. Okay, so the angle enclosure between the tangent plane at which the liquid surface and the tangent plane at the solid surface, and the point of the contact inside the liquid is called the angle of contact. See here, so suppose there is a liquid surface. So here you can understand that this is your liquid surface, right? And the tangent on liquid surface as well as the tangent on the surface at which this liquid is being touched. Okay, so the angle enclosure between the tangent plane at the liquid surface and the tangent plane at the solid surface at the point of the contact. So these are the point of the contact inside the liquid is called the angle of contact. So this is called angle of contact, and values of angle of contact lie between 0 to 180. So I will give you some more example where you will able to understand. So suppose this is your liquid drop, right? So this is the surface angle and the tangent of the liquid drop is here. So can we tell that this is your angle of contact? Now let us consider the liquid drop is like this. Okay, so the tangent at the surface is this, and the tangent at the angle liquid surface is at this solid and liquid surface. So angle between them is your theta. So this is your acute angle, and this is your obtuse angle. That is, angle is more in bubble, angle is more in drop, angle is more in drop, angle of contact. But as soon as you go where liquid starts wetting, so angle is less. Okay, so now the value of angle of contact will determine the whether the liquid will sprayed or will be in the form of droplet. Okay, so suppose here angle is very less, so it will sprayed, right? But as angle of contact is very much high, so it will not spread, it will be in the form of bubble, it will be in the form of bubble or drop. Got it? Now dependence of the angle of contact. As temperature increase means surface tensile will decrease, and hence angle of contact will decrease. See here, drop is, suppose this is your mercury drop, it means that it has high surface tension. So why it is high surface tension? Because it has more angle of contact. So surface tension is directly proportional to angle of contact. So if there is more angle of contact, it means that it has more surface tension. See here, this liquid has less angle of contact. It means that less surface tension are there. So before going through this topic, so we go to previous video so that you will able to understand actually what is surface tension and surface energy. Now it also depends upon the nature of the solid and liquid of the contact. Okay, so it is not only that only angle is necessary, but it also depends upon the what type of liquid you are taking, what type of solid you are taking. Application: wetting agent and waterproofing agent. Somewhere it is used as wetting agent, somewhere it is used as a waterproofing agent. For example, if you want to wet, so you will apply a water. Okay, but if you want a waterproofing agent, so you may use oil. Okay, so these are the wetting agent as well as wetting means what? If you want wetting agent, so it means that you need angle of contact should be less. Angle of contact should be less. It means that surface tension should be less. And if you want waterproofing agents, then you have to take material with high surface tension. Got it? Now what about excess pressure inside the drop? So what about the excess pressure inside the drop? So let us consider this. You know that drop. Why drop is a surplus? Why does not it brushed? Because it is giving a excess pressure from inside. So how much excess pressure is there? Why it is happening? So let us consider a bubble are in the form of equilibrium under the following three forces. So bubble are in the equilibrium. Neither it is bursting, neither it is coming. It is diminishing. Okay. So due to external pressure. So suppose there is an external pressure P1, that is pi r square. Due to internal pressure, so P2 is inside pressure, liquid pressure, liquid bubble pressure. We are talking about not liquid. We are talking about here bubble. Okay. But we are not talking about drop here. So this is your bubble. So there will be bubble. In bubble, what is happening? Air is inside the bubble. So the cross section of an air bubble of a radius r. So it has a radius r. So due to this, see here, how many pressures are there? External pressure is your P1. P1 is applying external pressure. Internal pressure is P2, that is from inside pressure P2 is being applied, and due to surface tension of the liquid. So surface tension of the liquid, so here surface tension is being applied. Okay, so at any layer, any cross section area. Now since here, see here, drop is in the equilibrium, so pressure from outside should be equal to pressure from inside. So what is the force from outside should be equal to total force from inside, right? So how you will do this? See here, if total area is here, you are talking about this area, okay? This type of area, we are talking about this type of area. So pressure P1 is applied, and what is the area? Pi r square. So how much it has a force? So it has a force F1 from outside. Now what is the force inside? So P2 into pi r square, because we are talking about this area only. We are talking about this semi circular area, right? Plus how much surface tension? So you know that surface tension is only acting on the surface and surface length. So surface tension per unit length is your S, and total length is your 2 pi r, so that you will get total force. So let us consider surface tension is equal to force by per unit length. So can we write here force is equal to surface tension into length? So here length is how much? Length is your 2 pi r. So we can multiply it by 2 pi r. Okay. Now if you see here, P1 pi r square minus P2 pi r square. So pi r square will be common. In this is equal to S into 2 pi r. So pi got cancelled. R square got cancelled. So pressure difference is equal to 2 into S divided by R. So that is the excess pressure. This is the excess pressure. That is pressure from outside minus pressure from inside. Okay. So this is the excess pressure. So this is the excess pressure inside the liquid drop. Okay. So here one thing you need to notice here. I have written here drop. If I will talk about soap bubble, that will be different, but this is your drop. So this is your excess pressure inside the drop, and it has formula excess pressure is equal to 2 into surface tension by R. Now if we talk about bubble, soap bubbles, so you need to understand that what is happening here. So let us consider, see here, you know this bubble is forming like this, see here, and this has two layer, outside layer and inside layer, and inside there is only air only, right? So as soap bubble forms two liquid surface, one outside and of the bubble and one inside the bubble, because inside is also there is a surface. So force due to surface tension will be how much? 2 times the surface tension into 2 pi r. Earlier what I have taken? Earlier I have taken surface tension into 2 pi r only. but it will be 2 times in a saw bubble, because we are getting two surface, inside surface as well as outside surface. So total force due to surface tension is your 2 into S into 2 pi r. Now here, since bubble are in equilibrium, so outside force is your P1 into pi r square, and this is equal to inside pressure. See, inside pressure is how much? Same. See, suppose let us consider this type of section you are taking. Okay, this type of section you are taking. So this section has pi r square, and here it is your it is your inside pressure P2, and here it is your outside pressure is your P1, right? So the force applied will be P1 into pi r square from outside. Force applied from inside is your P2 into pi r square, right? Okay. So here we can write here P1 into pi r square is equal to P2 into pi r square plus 2 into S into 2 pi r, because inside there are inside pressure as well as surface tension, pressure due to surface tension. So finally we are getting this equation. See here, I don't think it is you are getting problem. Now you just subtract this P1 minus P2 and take the common P pi r square, and this is equal to 4S into pi r. So finally you are getting del P is equal to 4S by r, and this is your axis pressure. This is your axis pressure, right? So this is the axis pressure inside a saw bubble. Not only saw bubble, wherever you find a bubble where inside there is a air and outside there is also air, so you have to find axis pressure by using this formula. Okay, so I hope you have understood this now. Now the next most important is your capillary rise. Okay, see here, capillarity action, you know why happen? Because liquid is waiting and it's try to move. See here, a glass tube with a fine bore and open at both the ends is called capillary tube, and the property by virtue of which liquid rise or depress in a capillary. Sometimes what happen, it rise or sometimes it got depress. So it may happen like this here. It may happen that it may depress, it may get depressed, and this is called capillary action, rise or fall of the liquid in the inside the tube and forming a meniscus like this. So it is known as capillary rise. What is the reason for this? Is the difference in a pressure. So here it is your low pressure upward above and high pressure below. So there is a difference in a pressure, and due to this difference there is a rise. Okay. Now let us proof here. Now tell me, vertical force due to surface tension. Vertical force due to surface tension is how much? So you know that surface tension is acting in this direction at an angle theta. So surface tension has two components, that is sigma cos or S cos theta. You can take S cos theta because we are taking here everywhere surface tension as S. So this will be S cos theta. Okay. Now at the same time there will be an S sin theta. There will be an S sin theta. Now what happened? Every side there will be an S sin theta. So if the surface is like this, there is S sin theta. There is also equal and opposite direction. All S sin theta component will cancel out each other. So you will get what? You will get upward S cos theta, total S cos theta. So total tension. So if I am talking about 1 point tension is your sigma cos S cos theta. You want total vertical force. So how you will find total vertical force? S cos theta into total length, that is equal to 2 pi r. So acting in upward direction, both all are acting in upward direction. Now the force acting downward is the weight of the liquid. W is your weight. Now weight, you know that it is your mg, and mass is your volume into density of the liquid into g. So can we write here volume as pi r square as? See here, let us consider this is your radius of the liquid, and this is your height of the liquid rise. So can we find here volume as equal to pi into r square into h? So can we put here pi r square into h? So we have put this pi r square h into rho into g. So finally we are getting weight is equal to pi r square into h into rho g. Now, as this situation is in equilibrium, neither it is going too much up and neither it is going too much down. So, equation 1 and 2, that is equation this equation, I am talking about this equation, okay? This equation, that is this equation and this equation, both are equal. Weight and as well as tension, force due to tension is equal. So, as the situation of equilibrium equation, so as cos theta into 2 pi r can be written as pi r square into rho g. So pi got cancel, r got r square got cancel. So finally you are getting height in the rise in the capillary tube. So h is your height rise in height of liquid in capillary tube. Liquid in capillary tube. Capillary tube. Okay. S is your surface tension. Theta is your angle of contact. R is the radius of capillary. Radius of capillary. Okay. So I hope you have, and rho is the density of liquid. Now if density is high, height rise will be low. If density is low, height rise will be high. G is the acceleration due to gravity. So in this way, you will able to find a rise in a height. Okay. So I hope you have understood these things: capillary rise, axis pressure, as well as angle of contact. So these all are our today's topic, and I hope most of the fluid topic I have completed. And those who want to go further, so go to all the videos step by step so that you will able to understand. And I will come with the separate section of the numerical. So if you want to know, if you want to solve more and more problems, so please visit us regularly so that I will able to give you numerical solution as well as, okay. So it will be very interesting to connect with you. Thank you for